In the last video, we looked at how to solve linear relations, linear equations, with a table of values or with a graph. In this lesson, we're going to look at a third way. Did you guess it? It's algebraically. So we're going to use special solving steps to be able to solve it. So it's helpful to have the question nearby, and since we have to look on a different spot, we're going to copy this and paste it in a visible place. Okay, so algebraically means we're going to manipulate, we're going to use the x and y's, we're going to use steps, and we're going to solve it. We're going to find an exact answer. Sometimes when we're using a graph, we have to guess a little bit if things don't land perfectly at a whole number. Algebraically, we should be able to find the exact answer. So we have y is equal to 2x plus 1 and y is equal to 9. Find x. So there's two variables in this. They're giving us the number for one variable and we have to find the other. Whenever you're asked to solve something, if there's two variables, they'll give you the information for one and then you have to find the other. So we're going to sub in 9 for y. So 9 is equal to 2x plus 1. Now our goal is going to be to get x by itself. So eventually at the end it's going to say x is equal to a number. So we've got to get rid of the 1 and we've got to get rid of the 2. The tricky part is deciding what to get rid of first of all and also how to do that. So I'm going to start just by telling you we do the opposite of BEDMAS. Whenever we're trying to solve. We're starting further out and we're working our way in to the x. So we're going to get rid of any addition or subtraction first of all. And how do we get rid of it? Well, if we're trying to get rid of plus 1, we need to do the opposite. We need to take away 1. Oh, that's great. Now that's going to be gone and we're just going to have 2x. There's only one problem with just getting rid of the 1 on one side, and that's it. An equation is kind of like a teeter-totter or a set of scales, anything that has balance. So let's imagine that this equation is a teeter-totter. And over here on this side, we've got a weight, maybe a person. We've got 9 over here. And it's perfectly equal to 2x plus 1. This is a box, and its weight is completely equal to this weight. Now if we reach into this box, and if we take out that 1, what's going to happen to the teeter-totter? Well, this just got lighter, didn't it? So the teeter-totter is suddenly going to go bang on the ground, and it's not equal anymore. So if we want to keep this balanced, what we do to one side, we have to do to the other. Well, that line doesn't look very level, does it? Okay, so what we do to one side, we have to very quickly do to the other. So if we're taking 1 away from this side, then at the very same time we need to take 1 away from that side. Then we'll have a nicely balanced equation. We'll be down to 8 over here and 2x over here. Perfect. We have balance. So we're trying to get x by itself. So we have 2 x's in here. We have twice the weight. How do we get rid of that? Well, we have to have half the weight. We have to do the opposite operation. So right now we have 2 times x. We need to divide by 2. Okay, so we divide by 2, we'll be down to x. If we take half that weight though, this side is going to be so light, and we're going to have the same problem as we did up here. The 8 is going to be heavier. It's going to be stuck down at the bottom, and the x all by itself is going to be stuck at the top. So if we take half the weight away from one side, we need to also take half the weight away from the other side, and that keeps it balanced. Then we get down to 4 is equal to, oops, not 2. Did anyone catch that? I made a mistake. What's the mistake? 4 is equal to x, because 2 divided by 2, that's how we got rid of the 2's. They're going to be gone. Okay, so this was like a picture to represent what's going on. I'm going to get this picture out of here, and we're going to see what it looks like in real algebraic steps. Not bad. Okay, so you might have to write out lots of steps at first, and that's okay. I'll try to write out lots of steps for you as well. It's better to write more steps and not make any mistakes. So we said that we were going to do 2x plus 1. We want to get rid of that 1, so we're going to subtract 1. And what we do to one side, to keep it equal, we have to do the same thing to the other side. So that's how we write it. This is called the balancing step. Just like the teeter-totter, it's keeping it balanced, it's keeping it equal. So on the next line, we have 8 is equal to 2x, because plus 1 minus 1, they cancel out. We were trying to get rid of the plus 1, so we did the opposite operation and we took away 1. And remember the opposite operation in this, 2 times x, the opposite is divide by 2. And what we do to one side, we do the other. If we're taking half the weight from one side, we need to take away half the weight from the other side. That's how we keep it equal. Okay, now if 4 is equal to x, then x is equal to 4. We usually write the variable first. We could say, therefore, x is equal to 4. Help me out a little bit, put a box around your final answer, just in case you've got a bunch of messy work like I have over here, then it does help to put a box around your final answer, draw your attention to the correct answer. Now let's see if we got the same thing graphically. Yeah, so we used the table of values, and that worked out really well. But if our answer, instead of it being x equals 4, had our answer been something like 2.5, we may have had a tough time trying to figure out what that value is. Or if x was equal to 100, maybe it would take us a while to get up to x equals 100. Maybe we would have decided to skip some steps and move ahead. Maybe not. Using the table of values works, but the algebraic way always works, and sometimes it's a lot easier. Same thing for graphing. Graphing's a great strategy. It works out so perfect when we get nice whole numbers. But if I would have asked you when y is equal to when y is equal to 8, what is x? Ooh, that's a little bit tricky. Well, I can safely say x is somewhere between 3 and 4, but it's pretty tough to say exactly what it equals. 3.6, maybe? 3.5? It's hard to tell exactly, because my line's probably not perfect. But in this case, we could solve it algebraically and get that answer, an exact answer. Either way, whether we use a graph, a table of values, or algebraic solving steps, we should get the same answer. It just might be more accurate if you use algebra.